Welcome to homework.
All right, we've got a reaction between acetic acid and triethylamine. And we need to show the mechanism, to give our curved arrow electron flow. Well, what kind of reaction is this? Recall that, acetic acid isn't a very good electrophile or nucleophile. Um, Triethylamine isn't a very good nucleophile. Um, so it's probably not any kind of substitution reaction. An elimination reaction also would not make sense because we don't have a leaving group on uh, either of these. Triethylamine is rather basic, but an elimination reaction wouldn't make sense without a leaving group. So this is probably just going to be an acid-base reaction. So really, this is going to be a rather short mechanism. We just need to show the transfer of this proton from acetic acid to triethylamine. So we'll draw our lone pair here on nitrogen. And remember, reaction arrows should always mechanism arrows or curly arrows should always come from electrons and point to atoms. So it's going to come from this lone pair and point there. So that's going to represent the bond being formed between nitrogen and hydrogen. We also need to represent that proton is no longer going to be bound to the oxygen. So we show an arrow from the oxygen-hydrogen bond onto oxygen. And then we just need to draw our products, and I'll draw them down here because I have more space. We're just going to draw the same thing, but without the hydrogen, and recall that these two electrons that form the oxygen-hydrogen bond were left behind on the oxygen. Furthermore, since it lost a proton, it's going to have a negative charge. And when we draw our triethylamine, recall that we've gained a bond to a proton, as well as these electrons are now shared between the nitrogen and the hydrogen proton, which means this will be a positive charge. You can also just know that whenever nitrogen has 4 bonds, it's positively charged. And those are our products.